All right, good morning. So my name's Jake. I work for a company called Square. To start with, I want to kind of figure out who you guys are and how I should level this talk in terms of complexity. So raise your hand if you are an Android developer. Okay. How about if you work on like server stuff, like cloud platform? Okay, a few. And then are the rest kind of JavaScript web people? Yeah, if you're okay. So for the last group, hope you have some games on your phone or something. Retrofit is a library by Square, and it's a Java library. So it's actually not Android specific, so it would work both for Android apps or on server apps, assuming they're written in Java. And this talk it's not really an introductory talk, although there's a introductory section. It's really kind of an investigation of how you can leverage the things inside the library that really aren't that well known to make it better, to make it do more work for you. And so I'll start off with a little introduction of what the library is, and then we'll go into kind of these really technical looks into how you can kind of modify the library around the behavior of your API or just oddities of your API and make it so that Retrofit's the one that's kind of masking over that instead of your application code. All right, so the whole idea behind Retrofit is that it is an abstraction on some remote API. So most, if not all, Android apps or server apps have to do some communication to whether it be another service or a remote API or whatever. So the way that you would model this in Java, if you were trying to abstract away, this like low-level network layer into kind of a higher-level interface, is that you'd write an interface and have a method kind of for each logical endpoint that you wanted to call. So in this case, where we want to perform some search, which has a query order that we want the results in, and then we're getting back some object that's like representing our domain. In this case, it's a list of users. And then what you would do if you were doing this yourself is you would implement it manually. You would implement this interface on a class, and you'd write a bunch of the HTTP code. And so it would be all kind of encapsulated here. And then your app or your service would just be interacting with this high-level interface. The point of Retrofit is to get rid of that implementation and just have it programmatically generated for you. So what we do is we use the interface as the source of truth, and we add a little metadata to it to describe what the actual corresponding request should look like. So we can annotate the method with the path, the API path that we want to hit. We can annotate each of the parameters saying what they actually represent. So the query becomes a queue on the end of the URL. The sort order becomes a sort query parameter. And so sort order here would be like an enum, and Retrofit will automatically call toString on it. And then the last change is that instead of just returning the list of user directly, so when you call this, it's like a synchronous call. It gives you back your object. In Retrofit 2, we actually force you to wrap this in something called a call. And a call is basically just the idea of this request wrapped up in an object that you can either execute synchronously or execute asynchronously. And so now you don't have to change your interface depending on whether you want to be synchronous or asynchronous. Not such a big deal for the server, but for Android, where you might be mixing the two, it's useful to only have to define these APIs once and then choose how you want to execute it later. There's all kinds of other stuff that you can do in these interfaces. So if you want to replace part of the path, you can add a parameter with an annotation, and then it has a simple replacement that it does. You can do posts. So if we want to upload an image, here you see we have an app body annotation, and the annotation on the method changed to post. There's all kinds of different formats that you can post to. Additionally, there's built-in support for creating multi-part requests, so you can have your parameters on the method wind up being different parts in the multi-part request. And there's also form encoding. So if you emulating someone submitting a form in the browser, you can have your parameters correspond to each of the fields. Additionally, you can specify headers manually. So if you have an endpoint that requires, some extra header, a content type or an accept header or whatever, you can manually add them. And there's a few more. There's actually a bunch of these. This is like the main interface to Retrofit. I mean, interface is like kind of the wrong word because this is an interface. This is like Retrofit's main API. This is where you spend most of your time crafting these to make them right and to make Retrofit behave how you want it to. And then the other half of Retrofit is actually how you take that interface and turn it into something that actually makes the request. And that's what this Retrofit object is. So all it requires is this base URL, and that's like the base on which all these relative paths will be appended. And then you can use this object to generate an instance of that interface. And now you have a fully functioning HTTP client that can interact with your API in whatever way you need to. And so usually we see these services, we call them services, these interfaces that have anywhere from like a handful up to hundreds of methods that are defining the contract of the API that you're talking to. And so now all your code is just programming against that high-level contract instead of being littered with kind of the low-level details of how the requests are actually being made, what format the parameters actually need to be serialized in, how the URL is actually created, building multi-part or form URL encoding or some other encoding. And also dealing with serialization. So if you saw that call object is still a parameterized on list of users. So we're still getting like our domain object. And Retrofit is going to handle that conversion automatically. And those are some of the things we're going to look at. But we're not going to be focusing on the interface at all. So that's really the part that's not that hard to pick up with Retrofit. The part we're going to look at is this other half, this Retrofit object, where the configuration lies. And here there's just a ton of power that's really underutilized. And so let's take a look at some of the things that we can do. The first is that Retrofit is not itself an HTTP client. It delegates to an HTTP client, but it's just this type that parses the interface, figures out how to make the requests, makes them, and then asks someone else to actually execute them. And so if we're creating these interfaces, like I said, a lot of times you'll see one, but if you're talking to multiple different services, usually you want to like split those up into logically separate interfaces. So you have like your user service, and then you might have your image service. And because those would be separate things if you were modeling them in just Java, we model them separately as interfaces because they're like two logically different things. And so this is fine. But what if they're at two different URLs? What if they're hosted by two different servers? You might create two Retrofit instances, and you actually have to do this in order to change the base URL. But it's important to note that because Retrofit is not an HTTP client, implicitly what you're doing here is actually creating two separate HTTP clients. And this is slightly unfortunate because there's a lot of really smart things inside of HTTP clients. There's things like disk caching, connection pooling. OKHTTP, which is the default client, has something called a route database, which remembers the best way to connect to the server you're talking to. There's all kinds of this information inside this client object that you've now broken and created like this split brain problem. And so you can no longer share that information. But the fix here is easy, right? This is like normal Java refactoring that we know how to do. We only create a single instance instead of two, and then we just pass it to both. But it's important to note that this is a thing that exists, and because we don't require you to supply it, you might kind of forget that one's being created. And that's kind of the theme behind a lot of this, is that there's a lot of hidden power that you just should be aware of because it can have really subtle effects. Another cool feature of this is because HTTP2 is becoming more and more of a thing, even though those hosts have separate URLs, they might live logically on the same box. And so if they speak HTTP2, even though they're different hosts, they could be routed over the same connection to the server. And so you wouldn't gain that if you had two of them. This is also important for the client itself because a lot of times you have to configure them differently for these different hosts. Maybe you're talking to a server that requires, the one server requires authentication. And maybe the other is far away, like halfway around the world, and you're uploading images, so the requests that you're making are taking longer. You might be tempted to just create 2 of these client instances and then configure them differently. You're going to wind up with the same problem where they're not going to share anything. Even though they're customized, they're not going to be able to share anything at all. What's nice about OKHTTP, which is, if I didn't mention this already, it's the HTTP client that by default sits underneath Retrofit, is it has this method called new builder where you can create an instance that's like the default, the baseline, and then you can customize the things that you need to, and basically everything that you don't touch will still be shared. So in this case, I'm adding an interceptor, which potentially adds like a header or whatever. But everything else in client foo that I haven't changed will be shared with client. So disk caching, connection pooling, route database. And then for our server that's halfway around the world, we can do the same thing, create another instance, and just change the timeouts to be longer. And so these are shallow copies. You're only customizing the things that you need, and the main one, the initial client at the top, is like the baseline configuration. And so now you can use client foo and client bar and pass those to our retrofit foos and retrofit bars and have that different behavior, but while also still getting all the benefits of having shared disk caching, shared connection pooling. So I talked about that interceptor might hypothetically be doing like authentication. A lot of times what you'll see is people have services where multiple of the endpoints require that header to be added, but then there's like one that doesn't. And so the way that you might solve this, and the way that we see a lot of people solve this, is inside their interceptor, where they go to add the header, instead of just always adding it, they check to see if it's that one endpoint they're talking to. And this is okay, this works. But it's a little sad, and that's because eventually what's going to happen is something is going to be added, like a forgot, login doesn't need authentication, obviously, because you're not logged in, but you're going to add something like another, like a forgot password endpoint. And that also doesn't need authentication, because if you forgot your password, you're obviously not logged in. And so what do you do here? Well, you have to remember when you're adding this to go back to that interceptor and modify the logic. And so that's unfortunate, because even though these things are separated, which is nice, you've logically coupled them and have to remember that when you update one, you have to update the other. This is unfortunate. So what we want to do here is try and figure out a way to separate this behavior so that we don't have to, we still have the coupling in the sense that it understands when to add the header or not, but we don't have to, when we update one, we don't have to update the other. So like an easy trick that we can do is use like what I call a marker header. And so what we're going to do is say, let's pretend that every endpoint by default is authenticated. And we're only going to specify the ones that don't need authentication. Instead of doing something like hard coding that in the interceptor, we can add a header to these endpoints, which is just a marker. Doesn't mean anything to the server, but it means something to us. And so in this case, I just called it no authentication. And what's nice is that in the interceptor, we can now look at that. Retrofit will add that header to the request, and then in the interceptor, instead of hard coding this URL, we can change it to just look for that header. And something you would also want to do here is probably actually remove the header if it's present, and then it never even makes it to the server. It never even leaves your client. It was only something you used for the behavior in your app or service. Eventually, we like to get to the place where you can do like a completely custom annotation. So you could say like @unauthenticated or something. But unfortunately, because these are two separate libraries, the interface was Retrofit. This interceptor is OKHTTP. They kind of don't know about each other. So eventually, we're going to probably do a Retrofit interceptor, which will intercept the request before it even makes it to the HTTP client, and that'll allow you to do things like C annotations. Anyway, I shouldn't be talking about the future. No promises for that. So this is like kind of a trivial example. More real-world examples would be like if you have endpoints where you can do gzip request bodies, OkHTTP doesn't do that by default. You have to opt into it. Maybe you want to log like metrics or timings in an interceptor, but only for certain endpoints. This is a great way to do that. Okay, so that's the client. The client sits underneath Retrofit, like I said. Everything else that we're going to talk about is in Retrofit itself, and so there's a lot more power that you can gain from it. The first is converters. So I said that Retrofit will still give you that like list of user in that initial example, that object that's in your domain, and converters are the mechanism through which it does that. These are the things that take the bytes and turn it into the nice Java bits, or take the Java bits and turn it into bytes to send across the wire. So by default, you can only use something called response body, but with this default like Retrofit setup, you can only use something called response body, and that's basically just like an object that represents the bytes in the response. So you could read this as like a string, or you can get it as a byte array or a byte stream or whatever. But that's not super useful, right? The whole point of these interfaces is we want high-level abstractions. We want this call to return list of user. And so the way that you do that is add something called a converter. And this is what you usually see is people add one for some JSON, usually JSON or Jackson. And what this allows you to do is now not use response body. You can use call of user. And when the response comes in, Retrofit's going to ask this JSON converter to take the bytes, turn it into a user, and then we take the user that it gives us back, and we give it to you. So you get this nice high-level declarative interface. Similar to the HTTP client, what a lot of people don't realize is that when you create these factories, you're also creating an instance of the underlying like serializer. So in this case, it would be like the JSON object. And so if you have two of these, you're creating two instances of JSON. And while that's not terrible, if you don't know how JSON works, it's actually similar to the HTTP client, where it has all this internal machinery that can be shared. And if you're creating two instances, then none of that can be shared. So like, again, the fix here is trivial. It's just to recognize the fact that you have two, and then only like factor that out and only create one. So now you have a single JSON instance, which is really nice because if these two Retrofit interfaces that you define share any object in their model. So even like the Java ones like map and stuff. But if you have a user object in both your interfaces for Retrofit foo and your interfaces for Retrofit bar, the cache, the like JSON's internal model only has to look up and figure out how to serialize a user object once. Whereas if you had them separate, it would have to do that expensive work twice. So again, this just comes down to like recognition. It's worth noting that if you actually create your own JSON instance for like customization purposes, you're adding like your own type adapters or whatever, you don't actually need to create you don't actually need to only have a single factory. The factories are cheap. They cost like nothing. The important thing is just that there's only one JSON instance. But like as a general rule, I say if you're so that it's impossible to screw up. If you have more than one instance of Retrofit, just make sure you only have one instance of each factory that you're using. Okay. So an important thing that a lot of people miss, which because it's new in Retrofit 2, is that you can actually have multiple of these converters installed. And so a lot of times what you'll see is you'll have a service which is like returning JSON for everything. And then your server team discovers protocol buffers. And they want to start using protocol buffers, so new endpoints are being added with protocol buffers. What you could do is actually just create two Retrofit instances, two interfaces, and have one that's only the JSON endpoints, one that's the proto endpoints. But that's unfortunate because you lose like the semantics of the service no longer apply. We want these to be like the user service and the image service, not the JSON service and the proto service, because you're leaking implementation details into your app. And so if we change this example and say that user's a proto now, and this friends object JSON. How do we deal with this? Well, like I said, Retrofit allows you to add multiple of these. But what's important to note is how it figures out which one to use. And so basically what is going to happen is the first time you call the user endpoint, the method, this user method, it's going to look at the type that you want. And so in this case, we're calling the user one. And user was the proto, if you don't remember. And what it's going to do is just going to go down the list. And these converters have a mechanism for saying whether or not they can handle a type. And so it's going to go to the proto converter factory and say, can you handle a user? And if you know anything about protocol buffers, they're generated classes, and all the classes extend from the same type. And so all this proto converter does is say, well, does it extend from the prototype? And in this case, it does. So it says, yes, that's the converter that's used. For friends, which we said was JSON, it's going to do the same operation. Goes to the proto factory, says, can you handle friends? Well, friends is the JSON type, the type that we probably hand wrote. Doesn't extend from the proto object. Proto converter says no. Moves to the next one, which is JSON. Because JSON can basically serialize anything, when we ask it, it always says yes. So yes, JSON can handle friends. And that's actually really important to note because that means that the order of these things matter. If you were to flip these and put JSON at the top, every type that you would ask it, it would say yes. So if you asked it for the user type, it would say, sure, I can serialize the user, and it'll just figure out what's inside and serialize it as JSON. But that's not what you want. And so it's important to understand the behavior that's going on here so that you know which order to put these in. If you don't know the behavior, each of these converters, the Java doc describes like how they behave. So one's for like proto, and there's also one for a library called wire. Those ones are very specific to the types that they handle. The JSON one, or the JSON ones, which is like JSON, Jackson, there's one called Mashi, and XML, the XML converters, they say yes to everything. Okay, so I just said that the order matters because when we ask, we want to make sure that like the most specific is first. But what happens if our server team is moving from, instead of going from JSON to proto, they're going from XML to JSON? I just said that both the XML converter and the JSON converter say yes to everything. And so if we were just to naively install these both, whenever it's asked, whenever Retrofit asks these, can you handle this type, the first one is just always going to win. It's always going to be XML or it's always going to be JSON. And then we don't get that nice behavior of having the semantic interfaces. We now have to separate the interfaces, right? That's what we see a lot of people doing, but turns out that's not the case. Something that we can do is actually just define our own annotations. So we can have one for XML. We can have one for JSON. And then we add those to the declarations. And so this isn't magic. Like Retrofit doesn't just magically pick these up. But what we can do is use the fact that we can write our own converter to inspect and look for these annotations and then delegate to the right one ourselves. So instead of installing both of these and having it not work, we can wrap them up into our own factory, which will look for those annotations and pick the correct one. So instead of putting the JSON and the XML ones to Retrofit directly, we create our own converter, and that converter is going to have the XML and the JSON ones inside of it. But what's the implementation of this look like? Is it horribly complicated? It turns out it's pretty easy to do this. So there's a few methods on converter because it can do both bytes to Java, Java to bytes. And there's actually a third one that does Java to string. And that's for like remember the sort order in the very beginning? I said it was an enum and it calls toString on it. That's like the default converter for things that go into the URL. It just calls toString on it. But you can create your own. Anyway, I'm getting off track. What's nice about this, so this is the response body. This is going from bytes to Java. What's nice about this method is that we give you the annotations, we being Retrofit. And so what you do here is trivial if you're given an array of something and you're looking for an element. You loop over it. You check if the element's equal to the thing that you want to look for, which in this case is the XML one. And then we just delegate to the XML converter. So our converter is assuming the responsibility of figuring out which one to delegate to, but then just the normal behavior takes over, the normal XML behavior, or we can add one for the JSON, and then at the end we have to return null in case we see neither of them. And so this is by the way, this is the mechanism of asking. You either return something or you return null, and null means that you can't handle a type. And so in this case, in this instance, we force you to choose XML or JSON explicitly. If you wanted to, you could just have one be the default. You could have JSON be the default and then only annotate the XML ones, or vice versa. But this is like what, 6-ish lines of code, and you've now solved that problem where if you didn't know this was there, you would have split the interfaces and made an XML and JSON one, and that would have leaked into your service or your app, and it would have to know which one to call, and when you converted an endpoint from XML to JSON, you would have to change all the call sites. 6 lines of code, and you can now hide that completely inside Retrofit. So this is very one-off. 6 lines of code, it's not too bad. I wrote a quick one. You don't have to look at what this does, but I'll actually have this online later. Oh, by the way, slides will all be online as well. I wrote one that uses a map instead, and it has like a fancy little builder. And so instead of being explicit about it, where we define the XML and JSON ones inside the converter, this new one basically works for anything. So you just create a builder. You say, here's the annotation I want you to look for. Here's the converter I want you to use. So you could reuse this. You could change it very quickly. So this will eventually make its way into the Retrofit project in the samples, if you actually want to use this. OK, so another interesting aspect of converters is this thing called delegation. And so this interface that we defined, going back is always scary. This interface that we defined wants a user object. And what's going to happen is the bytes are going to be given to JSON, and then we're going to ask JSON to take those bytes and turn them into a user. So what you would want to see on the wire in the bytes that are being returned is the user object is the root object of the response. A lot of times what we see in APIs is they wrap this in what we call an envelope, which basically is just some metadata surrounding the actual response, which has service-specific things. And then the type that you really want, the type that your calling code wants, is like inside some property. What you can do is just write that envelope as a class and then change your service to return envelope of user instead of just user directly. This works fine. But again, you're now leaking kind of an implementation of the service that you're calling into your calling code. So the code that's calling these endpoints has to unwrap the envelope. It has to, if you need the data that's inside of it to like log it or report it or whatever, everywhere that you call this endpoint or multiple ones that have this, that code has to deal with the envelope. So we can solve this again with a converter, except this time, instead of delegating directly to like other converters that we have, which we did in the case of XML or JSON, we're going to do a different form of delegation. OK, so the other 2 parameters that these converters are given are the type. And this is the type that's inside the call object. So we want this to be user. And then the other one is we're given the Retrofit interface or the Retrofit object. And you'll see why this is important in a second. So we want the type to be user. We want the type that is exposed to our app to be user. But we want the type that's deserialized from the bytes to be envelope of user. So JSON has a method that allows you to make that conversion, where we're saying, I have the envelope class, and I want you to parameterize it with the type that's passed in. And so enveloped type here will now represent envelope of type. So we've taken user, and we've now wrapped it in envelope of user. And then we use this retrofit object, and what we say is we ask it for the next converter that would have been used if the converter that we're writing, that we're in, wasn't there. Say, give me the converter which you would have used if I wasn't present. And so in the case of JSON, this would be like the JSON converter. And we're also passing in the envelope type, not the original type. So we're saying, give me a converter for whatever serialization format for envelope of user. And you'll see that it's the type that it returns is a converter from the body to envelope of whatever the type is. We actually don't care what that inner type is. We just know that it's wrapped in envelope. And then what we're going to do is we're just going to wrap that converter in our own that opens the envelope. So a converter has a single method, takes the body, returns, in this case, some object. We delegate. We call the converter that we asked. We call the next converter, and that converter will take the bytes, and it will turn it into envelope of user, in this case. And so we get back envelope of, in this case, user, but it could be any type. And then we just unwrap the envelope. We take that inner response, and we return that. And so we've created a converter which allows us to define. We can define that user type in our interface, the type that we care about, the type that our code wants to interact with. But the type that's actually being deserialized into is envelope of user. We just never see that. And so we've hidden this implementation detail of the API inside Retrofit instead of leaking it everywhere into your app. And so what we do is we just add this first. And again, order matters. Because we're asking for the next converter inside, it has to be at the front. And so this allows us to define call of user instead of call of envelope of user. And now all your application code never knew that the API wrapped the response in this weird JSON envelope. But this envelope stuff is usually put there for a reason. If your server developers or your API developers that you're talking to are reasonable people. And so you don't want to just throw this away a lot of times. I mean, sometimes you do, and that's fine. What's nice is that this converter gives you a central location to act on that envelope. So if all you're doing is logging metrics, reporting analytics, even if you're grabbing, in this case I had notifications, which are it could be app level notifications. You could pull them out and dispatch them to some central handler for this information. But yeah, this gives you a place to only do that once instead of having that code leak across your entire service or your entire app. Just for another example, a lot of times we'll see APIs that you're talking to, especially if they're written in Ruby for whatever reason, return 0 bytes when they actually mean to return null. So in protocol buffers, 0 bytes is a valid response. Everything basically gets the default value. In JSON, 0 bytes is not a JSON object of any type. You either want just an empty object, two curly brackets, or you can actually use what's called a JSON literal. You can actually put NULL, the 4 bytes, as the response, and that will turn into Java null. But for whatever reason, a lot of these endpoints wind up returning 0 bytes in that case. And so if you hand JSON 0 bytes and say, turn this into a user, it's going to say, well, there's no bytes here. I ran out of bytes trying to read this message. Again, a converter is a fantastic way to just paper over that. So we can write one which says, give me the real converter, give me the next converter that would otherwise be used. And then I'm going to wrap it, except before delegating, I'm just going to check to see if the content length is 0. And if it is 0, I return null. Otherwise, delegate to the real one. And so what is this, 4 lines of code? And you have that weird API behavior now becomes non-existent. Your app no longer has to care. And what's great is that you can build these up. So even if we still are doing the enveloping, we can put this null handling converter before that. And so the null one, empty to null, will delegate to the envelope will delegate to JSON. You can like build up these behaviors to fix weird inconsistencies of your API. And as far as your calling code is concerned, it knows nothing about it. It's just getting call of user, it's getting the user object. It doesn't know the serialization format, it doesn't know that the envelope is there, it doesn't know that your server developers, the API developers that you're talking to, aren't using a good language and returning null for empty. But it papers over all that like weird inconsistencies. Last one really quick for converters. There's this app called Plaid, which is by Nick Butcher from Google. And it has a really clever use of converters. So it's an app that exposes Dribble images. Dribble is like a designer service for posting posting your work. But it does have an API, Dribble, but it doesn't have a search API. So you can get like a list of images for some feed, but there's no way to search for something. But if you look inside this app, Plaid, it's called Plaid, you'll see this interface declared for Dribble search. And it takes query parameters. It returns a nice domain object, list of shot. Shot is like an image. And what you don't see is that there's a custom converter inside it, which I'm actually not going to show you the implementation of because it's self-described as being gross. And it is really gross, but it's also a really clever use of converters. So if you're interested in the implementation, it's there. You can get that link on the slides at the end. So we know we have Dribble. We know we are getting back a list of shots. And we know this converter is sitting between them. So every website, Dribble's a website, not just an API. Every website has an implicit API, which is I can hit it with a URL, and I can get back data in a certain format, and then I can have a client parse that format. And what I'm talking about, of course, is HTML and the browser. Browser is basically an API client. HTML is basically a serialization format. And then the browser deserializes that into something that you see. And what you can do is actually do the same thing. And even though this is kind of gross, it turns out working really well. So what he's doing is hitting the search endpoint for the web, not for the API. Using a library called JSoup, which allows you to pull out bits from HTML, and then basically just manually grabbing the information that he wants and turning it into this shot object, which then gets put into a list. And so this is just a really clever encapsulation of basically super gross HTML parsing code. But in terms of the API, it's super nice because he's now encapsulated that inside this converter. It basically becomes a black box. So you do this once, it's gross. Occasionally it will break because they'll change their HTML or whatever, and you go in and tweak it. But you've essentially turned it into this black box where you still get the nice types, even though you're talking HTML and pulling out this weird, these weird pieces of data. So it's just kind of another clever use that you might not think of to use Retrofit for. OK, so that's converters. Converters, like I said, bytes to Java, Java to bytes. It allows you to handle the serialization formats, whether it's one or many, and all their inconsistencies or oddities, and try and mask them to be something that's sane so that your app or your service is programming against a nice, semantic, clean API interface. Call adapters are the other half of the kind of request execution mechanism. And that's actually how the request is being made. So converters deal with the bytes and the objects. Call adapters deal with the actual execution, like the synchronous or asynchronous, the threading. So by default, I've been talking about this call object. And this call object is the built-in execution mechanism of Retrofit. It allows you to execute things synchronously or asynchronously. And so what's happening is underneath Retrofit, I talked about the HTTP client. There's actually an abstraction on top of that, so you can swap out the HTTP client if you want. but for the purposes of this, we'll just call it the HTTP client. OKHTTP itself has a call object. It's separate from Retrofit's call. It's basically the exact same. It serves the exact same purpose, but it doesn't know about the Retrofit level of things. So you ask OKHTTP to make a request. It gives you a call, and you can either execute that synchronously or asynchronously. Except what you get back at this level is bytes. You're dealing with bytes. You're dealing with request objects, and you're dealing with response bodies, which are bytes. And then the call of user is the Retrofit level, which knows how to do things like talk to the converters and turn those bytes into the types that you really want to be interacting with. And so a call of user, a Retrofit call, is just a wrapper around OKHTTP's call. And what's kind of unintuitive is that Retrofit actually wraps this twice. So we wrap it once, and we create call of user, and that's the one that talks to the converters, turns it into the nice Java types. And then we actually wrap it again before we give it back to you. This is the default behavior. And the reason we do this is, it's actually, is that true on the server? It's true on Android. I can't remember if we wrap it twice on JVM. But the reason we do this on Android is that we deliver callbacks on the Android main thread. And so the original Retrofit call that we wrapped the OKHTTP call with uses the same threads that OKHTTP uses. And so when OKHTTP calls you back asynchronously, it calls you on a background thread. And so that's where we can do things like the conversion from JSON to Java objects. What we need is another way to move back to Android's main thread to call you back, and so that's why we wrap it one more time. The mechanism that does this is the call adapter. And so the stuff on the left is always going to happen. We're always going to have an HTTP client. We're always going to create a HTTP client call object, and then we're always going to wrap it in the Retrofit call. And then the stuff on, or did I say left? It's on the right. The stuff on the actual left is the behavior that a call adapter creates, which is that extra level of wrapping. And just like the converters, this is behavior that you can customize. So like I said, by default, it puts callbacks on the main thread on Android. If you're doing this on the JVM, it just gives you the callback on the OKHTTP's background thread, its thread pool. We provide some call adapters in the library. They're separate artifacts that you can depend on. And so what they allow you to do is actually change from using call to really whatever you want. One of the ones that we provide is one for RxJava. RxJava is a, how do you even describe it in a few words? It's kind of like a functional programming, asynchronous, like reactive library. That was a lot of words. It's an execution mechanism. It's a mechanism for running code and then controlling what happens to it, including the threading. And so instead of using call, if you're already using RxJava for stuff, you can now have your interfaces automatically return RxJava types instead of just Retrofit types. And so these interfaces now become much easier to use with the code that you're already writing for RxJava because it now returns types in your, in the domain that you want to be working in. And so what happens here is basically you see on the right, we're still doing the part where we wrap it in Retrofit's call, and that's the part that's doing the conversion, calling the converters. But then the left part is the part that has changed. We've swapped the call adapter out, and so now instead of rewrapping it into another call, we're wrapping it into this observable type and using observable as the execution mechanism, the mechanism for threading. And what's great is you can mix and match these. So it works the same as converter. If you have ones that are in RxJava land, you can have them return observable, or you can just be returning Retrofit's call type if you want to be making synchronous requests, or you have an area where you don't have any threading model, but you still want to do asynchronous. And the way that this works is that we implicitly add a converter at the end, which knows how to deal with the call type. And so if you're the lookup mechanism for figuring out which one to use works the exact same way as converters. For observable, we just start going down the list. The first time you execute it, we grab the type and we just start asking, hey, can you handle observable? RxJava guy says yes. First time you execute the friends, we go to the RxJava one because it's first. Can you handle call? No, I can't handle call. It's not an observable. So we go to the one that's built in that you never see. We ask it, and it says yes to call. And so because of this, we can do all the same tricks. All the tricks that we learned in the last section, we can do all of them here. Another one would be, the other one that we provide is one for Java 8. So if you're working on the server, this is useful. You can get back completable future. So if you're already chaining stuff with futures, completable futures, hopefully, you can do that. The other one we provide is Guava. So if you're using listenable future in Guava, there's also one for Guava that does listenable features. OK, now's the part where I should have said we could do all the same tricks. So we can do all the same tricks that we did before in customization. The RxJava call adapter, by default, it's synchronous. So even though it's like with RxJava, it's traditionally thought of as like a way to like manage asynchronicity. By default, the observable itself is synchronous, but you can make it asynchronous by providing like a default. They're called schedulers, so basically thread pools. A default thread pool. And so now when you subscribe to this observable, it'll happen on a background thread. But for like Android, we've lost that convenient feature where we got callbacks on the main thread. So now every time you interact with one of these observables, you have to do observe on the main thread, observe on the main thread. Everywhere assuming that's what you want, everywhere that you talk to you call one of these observables, you have to have that explicit threading change. And so maybe we want that to be the default. When we create this observable, we want it to run on a background thread, just like the call, but we also want it to deliver results on the main thread, just like a call. Well, the built-in one doesn't do that. So what can we do? We can make our own that just delegates and adds the behavior. All the same tricks. So we check to see if the type is the type we want. So there's this convenience method called GetRawType. The type that you're given is the observable of user. So it's the like generic parameterized type. And this is how you like figure out what the outer type is. You get the raw type, which is just observable, and then compare it against the thing that you want. Return null, which means you can't handle it. That's fine. We delegate. We get the real call adapter, and then we wrap it. We call the delegate to get the otherwise type that would be returned, and then we add the behavior that we want. We add the explicit threading argument. There's this other method that you kind of have to return. This is like the inner type. So in the case of observable of user, we need some way to like figure out what that user is. And so that's what this does. You could just delegate. The built-in one will do the right thing. But that's it. So again, 7 lines. And you've now changed the threading semantics of all the observables that are going to be returned to behave how you want them to behave. So now your application code doesn't have to explicitly do threading calls at every single call site. By default, it will happen. This is another great place, especially in RxJava, for things like logging. If you have built-in logging, or you want to do like application level interceptors, where you can intercept like the user object before it gets returned to your application code. There's a ton of power here. So again, just add it first so that when we delegate, it picks the right one. And then it all just works. So those observables, like from RxJava, completable feature, listenable feature from Java and Guava, respectively. And call is from Retrofit. So if you have like your own crazy, maybe not crazy, if you have your own library that you're using, or even your own types that you've defined, which allow execution, you can just use those by writing your own call adapter that takes the call and wraps them in whatever type you want. And that allows you to change all your methods to return literally whatever you want. So just as like a quick example, a lot of people get frustrated with call because it doesn't actually give you the user directly. It gives you responsive user. And so this encapsulates like the headers, the status code, the message, and also the body, which is the user. You have to check whether or not, so we give you this responsive user both in the case of 200s and also in the case of any server response, so 500s, 400s. And so you have to check to see whether it's successful before you pull out the user. And when you do that, if it's not successful, we give you the body, but we don't try and deserialize it as user, because if it's a 400 or 500, who knows what the bytes actually mean? It could be coming from your server, and your server might be returning JSON, but it also might be coming from, it might be your server, but it's like a 500, which means your server is crashing, and so the application hosting your server will return maybe like plain text, or maybe it's a proxy that's between you and your server that's returning plain text, and it's like rate limiting you or something. And so this is the reason we don't try and deserialize the error response. We just give you the bytes. And so this can be annoying to some people because a lot of times they do want to get back some Java level object instead of bytes. Retrofit has only fixed the case of 200s, not the case of when you have a 400 and your server is returning JSON. So that can be annoying. What you can do is actually just build your own call. You can take call, which this is close to retrofits, but it's subtly different. You can take your own call, and instead of returning bytes for an error response, you can turn that into something that's parameterized. So instead of call of user, it would become call of user of error response, or whatever type you want to define for your error. And now when you have that error and you get that in your application code, you get your nice domain object that you can pull bits out of. You could even go so far as to get rid of the response type altogether. Maybe you split this up into multiple callbacks. So instead of just having success and fail, you now have success for 200s, error for any HTTP error, and failure for like the network is broken errors. Or you could go even farther and make a bunch more semantic callbacks. One's for 400s, one's for 500s, special case for 401 because you're logged out. Really, whatever you can envision, whatever you want your API to be exposed in terms of the execution semantics, if you can build it into like an interface like this, you can write a call adapter that will like implement it, that will back it up. And so whatever behavior you want in terms of execution semantics, we try and do something that's reasonable by default, but the power is there for customization. Okay, really quickly, we started a bit late, and I want to hurry up so the next person doesn't have to hurry. The last thing is Retrofit is something called Mach Mode. This is really only useful for probably Android. But the idea is if you have a service, because it's just an interface, you could just implement that interface and return fake data, and then program tests against that. So what you might do is just return data synchronously by implementing this interface, and swap out the real service for the fake service. This is okay. Retrofit has something called Retrofit allows you to create something that we call Mach Mode through a separate artifact, which is called Retrofit Mach. And what this gives you is something called a behavior delegate. And this is just allows you to apply HTTP-like semantics in terms of timing and failure. So instead of returning synchronously, it'll now return this stable response after maybe 2 seconds. And then occasionally it'll just throw an IO exception, which pretends like the network failed. And the way that you do that is you have to call into this. Instead of just returning directly, you call in through this delegate and then return the response that it gives you. There's a bunch of like boilerplate to set it up, but you only have to do this once. And in the end, you get the Mach service again. But yeah, the important bits are you have to call into that behavior delegate, and this network behavior is what controls how this fake HTTP layer behaves. So you can do things like set the delay. By default, it's 2 seconds, so everything just takes 2 seconds. Whether it's synchronous or asynchronous, it's going to take 2 seconds. We also give you a variance, which is like gives you a plus or minus on the 2 seconds. So it'll be 40% faster, 40% slower, just somewhere randomly between those two to give you kind of the feel of a network which changes delay over time. And then occasionally it fails, so you give it a failure percent. I think the default is 2, but it just allows you to test, especially for Android. Usually you're sitting on these like super fast Wi-Fis and you're like physically next to your server or you're on the same network as your server, and so it never fails. This is a way to just mix in occasional failures to make sure you're testing that your app behaves correctly when that happens. At Square, we take this really far. We can run our entire app in what we call Mach Mode. This is Square Cache. And so you see there's like fake users, there's fake payments. This never hits a server. It's also stateful, so you can like go and send a payment and it will be added to the list. But then like kill the app and restart it, and it's back to the original state. Super useful for writing like both unit tests and instrumentation tests against. If you want to see a sample, I wrote an app called U2020. It's getting a little old, probably needs a little love, but it contains Mach Mode. So it just hits the GitHub API for some trending repositories. On the left is the real data. On the right is mock data. Okay, so yeah, Retrofit, a lot of people immediately see the value in abstracting away the APIs that you're talking to, but there's so much more than that. And so there's the HTTP client, which controls the bits being sent across the wire, and that's a customization point. There's converters, which are the things that actually take those bits and turn them into Java objects. That's a great customization point in both directions. Call adapters, which is the execution mechanism, the thing that actually executes the request. Great extension point. And finally, Mach Mode, which is not an extension point so much, but just a way to, a feature that's really little known, but gives you great results for deterministic fake data that still behaves sort of like a network. And that's all I got. Thank you guys very much. If you want the slides, this is a link to the slides.